Hi, everybody. This is our CSE 312 social media group project, and this is made by Andrew, Vlad, Khan, and Gavin. So now we'll go into a demonstration of our app.
When the user goes to the app, what they will see is this login page right here. And if they are not a registered user, they will go over and click create account, which will bring them to the register page. And in this example right here, dog, and because the password did not meet the requirements of being at least the length of 8 and didn't have at least one capital and didn't have at least one special character, that user was not able to get created. And over here, it shows those requirements. And now this time, this user will put in their wanted username and the password that actually will meet the requirements. And this time when they click submit, they actually will be registered, and now they will be able to log in as the user with the credentials that they just used. It will be checked against the database, checked against the secure password in the database, and if it does match, they will be logged in and the following will be shown. Once the user is logged in, an authentication cookie will be generated for that specific user. And that authentication cookie will allow the user that even if they exit out of that tab, they will still be able to later go back to that site. And when they go on, they will already be logged in as that user.
Next, we'll demonstrate how there's a dark mode. When you click the button, everything in the page turns dark with the text turning white. And then this persists even after you log out. And when you relog, we'll see that the user is still in a dark mode, and you can change it back to white mode or light mode. And you can also see that now that you're logged in as dog, your own username is in the online users list, and there's also 3 more users, which is the other 3 members of the group.
Now we will be going into the post functionality. Now on the home page, the user can add in a post and choose a file to include in the post that is an image, and then describe in text what the content of the post is about. For example, this is a picture of a bee. And then this will, on click of the post button, this will be added to the home page. Now, if we log in with a different user, we should see that this post will be displayed on the user's home screen on login. There we go. Now let's add another post to see that sharing pictures will happen live with these posts, including a picture of this cat here. The image isn't very in frame, but as you can see, it was shared live.
As you can see, I'm logged in with 3 users right now. But if I send a message to test, so this will only go to test, and he'll receive an alert, a notification, and he'll receive the message. But you can see the other user is not receiving this message. Only test will receive the message.
Now you will see that user test will log out, and here in user A's browser, test is removed from the users list.
Now, after that demo, we are going to go into the software architecture of our project. Now, in terms of the file layout for our project, most of our data lives within the source folder and the server folder within that. There is a section for our database, the DB section, that has db.py. The static files are held in the static folder. This has CSS and JavaScript files, uploads folder is where user uploads will be saved. Most of our code lives in the server.py file. This handles pretty much all the routing of paths and processing of user data. There also is the templates folder, which has the HTML templates that are modified and then served to the user. Now for the frameworks and libraries.
Flask starts a WSGI server that manages HTTP requests. When a request is received, it creates an object that describes the environment about the request, which we call the request context. This is put into a local stack, and the same is done for application level data, which we call the application context. When a request is no longer handled, the request context and the application context are popped from the stacks. The context, while not global variables, are handled roughly like one. Functions from various classes will be using them. When we need to send a HTTP packet, we can use Flask to create a response object that manages headers for us, including cookies. Routing. A route can be called while interacting with the page. When that happens, Flask looks for and runs the functions right after that app.route is defined in the Python code. Templating. Flask looks for delimiters that aren't in HTML, such as curly brackets. Double curly brackets define variables, and a curly bracket followed by a %sign designates control flow statements such as if or else statements. HTML sanitization. While rendering the template, it also automatically escapes sensitive characters for us. Next, we will introduce Flash Socket.io.
So in Flash Socket.io, it helps sending data in real time, so you don't have to refresh your browser or anything. It will be in real time. And we used Eventlet here for sending data. So what Eventlet does is it helps for support. It gives support for long polling and WebSocket transports. So in our client side, Socket.io library, it does all the hashing and parsing. So we don't have to do a hashing and parsing separately. And also, like, you can emit the response from client to server, and also from from the server to client. And by default, all the messages will be broadcasted to the client. But if you specifically send message to a specific client, you have to use session ID and send in a specific room. Then next we'll talk about bcrypt.
One of the libraries we used was bcrypt. Bcrypt was used to salt and hash passwords in order to securely store the passwords in the SQL database. And now we will go to the next slide.
Now we'll talk about how our data is stored and processed. This primarily happens through MySQL tables. There are 3 of them. First is the users table, which the whole app is built around and user accounts are built around. This has a unique user ID for every user, and this is the primary key. The username column has to be unique in the table. The password, as mentioned before, is stored after being salted and hashed, and this is stored in binary. There also is a bool column to show whether dark mode has been enabled for the user or not. Now for the login table, this keeps track of all the currently logged in users. This references a user ID from the users table as a foreign key. This table stores the username as well as a authentication cookie to keep track of the fact that this user is indeed logged in. And this user will be added and deleted from this table on login and logout respectively. Now for the post table, this stores user posts that users have made. There is a unique post number which serves as a primary key. There's an author ID, which is a foreign key that references the user ID from the users table. This, for the posts, the file path where the image is stored is an entry. Also, the other columns involve the title of the post and the content of the post. All of these tables are accessed and modified using helper functions which use SQL prepared statements, and this helps to prevent SQL injection attacks from user inputted data. Now for all of our criteria.
One of the 5 criteria was user accounts. When a user account is created, the inputted username is checked to make sure that the same name is not in the SQL database as an existing user. In that case, no two users can have the same username. There's also a check on the inputted password to verify that the password contains the required characters for security purposes. If both criteria are met, then the user is created. Their inputted password is salted and hashed for security purposes. The salt is stored in the user's data row. When an existing user goes to log in, the inputted username is checked in the database, and the password in the database is compared with the inputted password's result after being salted and hashed using the salt from the database. If the username and password are verified, then the user is logged in and an authentication cookie is given. After that, the user's HTTP requests will be checked for the authentication cookie in order to allow actions. There is the dark mode button in which a user can click that button and it will change the CSS class and change the appearance of the site where black and white will be inverted. Now we will go on to logged in users.
When users log in, they will be added to the login table of the database as stated in the last slide when a cookie is set for them. Only upon logout, aka when a cookie is removed, will the user be removed from the login table. At any point when the page is refreshed or when a user logs in, a get function is called to receive the whole list of logged in users, which is then rendered as buttons on the page.
Now we'll talk about messaging. One of the requirements for messaging was it has to be on real time and it has to be through WebSocket. So we fulfilled the requirements. We used Flask Socket IO and it's in real time. And we had like two kind of messaging options here, and users can send a public message. This message will be shown to every users who are logged in. And also users can choose a specific user to send message. A chat box will open when you click the user you want to send message to, and this way only receiver will get the message along with a notification showing he or she get the message, who he get the message from. Now we'll talk about sharing the post slide.
So, involved in sharing the posts is the storage of multimedia and images. Images in the posts are saved in the uploads folder. This file name that is inputted by the user with the file is put through a function to make sure the user doesn't have access to arbitrary files in the file system. The live sharing of posts happens through a WebSocket broadcast containing all the post data and the image, which is added as a link to the path that the image was stored at on the server. Accessing this path does require authentication, so these images are kept private to logged in users. All user-entered fields, such as the title and post content, are also HTML escaped. And now for the endpoints of our app.
For the endpoints, the web server runs on port 80, which is HTTP. and the SQL server is running on 3306. The / path leads to the login page if the user is not logged in and does not have an authentication cookie, but will take the user to the main page if the user is not logged in. The /login path leads to the page where a user can log into their account. The /register path leads to the page where a user can register for an account, and as long as they meet the criteria of a strong password and a non-existent username in the database, the account will be created. And now we will move on to our reflection. Reflecting back, we could have started earlier and tried to have more done by the first checkpoint, as well as more documentation and reports written up by then so we could have gotten more feedback. We learned the Flask framework and got more experience with an SQL database. Some difficulties were encountered were that two members had trouble running the server on their machines once the SQL database functionality was implemented. This led to difficulty for both of those members to code since they had to write code without being able to quickly check their output by running the server and testing locally. Now we will move on to the next.
Version
Sorry.
control branches and pull requests and merges on GitHub were skills that we needed to learn in order to code collaboratively with version control. These are skills that will most certainly benefit us in our professional careers, but there was some trouble for some users, some members of our group, to use these skills well. For as far as peer programming goes,
As Vlad mentioned, we didn't have that much idea about the library of Flask and Socket.io and also MySQL. So we had to learn everything from scratch. So that was giving hard time at the beginning to understand someone else's code, like if they wrote anything with the Flask. So I was having hard time to understand because I didn't have that much idea about Flask. So and also with the environment, um, with the GitHub's environments and everything, it was kind of overwhelming from at the beginning. It was easier than the homeworks, and um, Gavin will talk about this.
Yeah, the project overall was easier to manage compared to the homework since we had access to libraries and we already had experience with concepts we needed to know from doing the homework. Additionally, we had lower workload since the project could be split among the team, even though admittedly it wasn't split equally, which is another thing we could have done better.
Overall, this project has been a great learning experience for all of us, and we got to learn a lot about software engineering while improving our teamwork and programming skills. We hope you enjoy our app.